Hey guys, what's up? You are watching Physics Lad, and today we are going to discuss a TAFR GS 2010 physics problem. So this problem is basically about gravitation or central forces in general. So let us see the problem, what they have given, and try to get the answer. Okay. So the problem is a small meteor approaches the Earth. When it is at a large distance, it has a velocity v infinity and impact parameter b. I'll explain you what the impact parameter in a while. And if re is the radius of Earth and v0 is the escape velocity, the condition for the meteor to strike the Earth is, and they have given 4 options. Okay, and so how are we going to solve this problem? First of all, we have to give the diagrammatic representation of the problem and identify the crux of the problem, what the problem is, and what the examiner is trying to convey us. Okay, so here I have drawn a diagram of the problem they have given. So here is a meteor, and it has velocity v infinity, and it is traveling towards Earth. It has mass small m, and this is the impact parameter. Okay, here this is the center of Earth, and the height above which the meteor is situated from center of the Earth is this impact parameter. Okay, why I have taken the center of Earth? Because of the center of mass concept. Okay, it is in such a way that the whole mass of the Earth is concentrated at the center. Okay, the particle assumes in such a way that, and it behaves like so. Okay, so it is traveling with the velocity v infinity, and here is our Earth, which has radius re, mass capital M. Okay, so what they are asking in the problem is the condition for the meteor to strike the Earth. So the meteor is traveling at certain height with some velocity, and it should strike the Earth instead of escaping the Earth and following this kind of parabolic path or else hyperbolic path, whatever it is, based on the velocity. Okay, how are we going to solve this? First of all, let us consider the case where the meteor misses the Earth and just travels through this parabolic path and gazes the surface of the Earth. Okay, and for that, how are we going to find out what the impact parameter when the meteor just misses the Earth? Okay, that is our first task. As we know, the gravity is a central force, so the angular momentum is conserved. The angular momentum at point A is equal to angular momentum at point B. Okay, so mass of the meteor into velocity at point A into height, impact parameter B, equals to mass of meteor into velocity at the surface of the Earth and radius of Earth. Actually, angular momentum is L equals to m into v cross r. Here the cross product vanishes because of the fact that velocity is in a tangential direction, this r is in a radial direction. So these both quantities are orthogonal to each other in cylindrical coordinates. So the cross product is just the magnitude multiple. Okay, product of v and r. So mvb equals to mv0 into re. So the m's get cancelled out, and v infinity by v0 equal to re by b. This is equation 1. And also always a mechanical energy is conserved. Okay, so here the meteor have kinetic energy when it is not under the influence of gravity, and when it is approaching the Earth, it is under the influence of gravitational potential energy. Okay, along with the kinetic energy. So only kinetic energy at point A, and kinetic energy and gravitational potential energy. Okay, so by simplifying this equation, we'll get this by taking the LCM and cancelling the m on both sides, we get this. Okay, and we also take out 2gm equals to Ra into v0 minus v infinity whole square as one equation. This is very important because as you can see in the options, there is no 2gm in any of these options, so we need to eliminate that out. So we need to write that in terms of radius of Earth v0 and v infinity, which were given in the problem. so I have taken this step. Okay, from let's proceed from here onwards. I'm taking v infinity common at the outside, and we get v naught by v infinity whole square minus 1. From equation 1, we know v infinity by v naught equal to re by b. So what is v naught by v infinity here? So it is just b by re. Squaring on both sides, we'll get 2gm by re equals to v infinity square into b by re whole square minus 1. We'll just jiggle around a bit and try to find out what is impact parameter. Okay, we will take the LCM and do some math. We'll be getting this quantity b square equal to 2gm re by v infinity square plus r square. If we take the root on both sides, we'll get the impact parameter. But what does this tell? If impact parameter is like this, the meteor will just grazes the earth, and it might or might not strike the earth. It might miss out the earth completely if impact parameter is greater than this quantity. If it is greater than this quantity, the meteor will completely miss the earth and it will travel along this path. But if the impact parameter is less than this quantity, the meteor is going to strike the earth, and that is what the problem is asking, the condition for the meteor to strike the earth. So here, instead of greater than or equal to, here we'll get less than. Okay, so b square less than 2gm re by v infinity square plus r square. And from equation 2, I have told you this is very important. 2gm equal to re into v naught square minus v infinity square. We need to eliminate that 2gm because it is not given in the options. So I am eliminating 2gm with the equation re into v naught square minus v infinity square, and I am substituting it here. Okay, and we'll be getting this b square less than v naught square minus v infinity square by v infinity square into re square plus re square. Taking re square common and doing some LCM, we'll get b square less than re square into v naught by v infinity whole square minus 1. Okay, and we'll take the root on both sides, and we'll be ending up with this, which is option number 1. See the same option, b less than re into v naught by v infinity square minus 1. So option is option A. So what we have done, we have given the diagrammatic representation of the problem first, and then we have identified that it is a central force, and we have applied angular momentum, conservation of energy, and we found out a situation for meteor missing out the planet, and from there we have concluded what could be the condition if the meteor strikes the planet, and we did the math, and finally we got this answer. So this problem is I think a little bit difficult for a novice physicist, but if you work out 2 to 3 times, it will be no big deal. Trust me, this is very basic concept. Only 3 steps are involved. You should identify that problem belongs to central force, and you should be familiar with the conservation of angular momentum, energy, and what is the condition if the meteor misses the planet, and from there you can get what is the condition for meteor striking the planet. So for today, the meteor is striking the planet, and we couldn't save the earth, but in JEST 2019 paper, JEST 2019 paper, they have asked a question in such a way that what will be the condition if the meteor misses the planet. So this kind of problems will be frequently asked in JEST, TIF or IIT JAM. So it will be better for you to practice this and master these kind of problems. Please practice this at least 3 to 4 times by seeing, and later on try it without seeing. Okay, and I also want to suggest you a book for these kind of problems, IA Eredo Problems in General Physics. Problems in General Physics, and David Morin, Classical Mechanics. This is very good book. I have read it and I personally suggest you to read this book. It is full of very interesting problems and it will improve your problem solving analytical abilities. Okay, thank you for watching the video and happy physicsing.